NENOMATICA, where mathematics meets YouTube excellence. The absolute value of x is the distance from 0. Formally, it is piecewise. When x is greater than or equal to 0, the absolute value of x equals x. And when x is less than 0, the absolute value of x equals negative x. Now, let's confirm this with 4 quick examples on a number line. First, positive 3. Because 3 is greater than or equal to 0, the distance from 0 is 3 units to the right. So the absolute value of 3 equals 3. Next, 6.5. It is still to the right of 0, so its distance is 6.5. Therefore, the absolute value of 6.5 equals 6.5. Now a negative input, negative 2. It lies to the left of 0, but distance is always positive. The rule says the absolute value of x equals negative x when x is negative, so the absolute value of negative 2 equals 2. Finally, negative 4.7. Again, it is left of 0, but the distance to 0 is 4.7. So the absolute value of negative 4.7 equals 4.7. Summary: absolute value measures distance from 0. It is never negative. If x is non-negative, the absolute value of x equals x. If x is negative, the absolute value of x equals negative x. Example label. Then we place the problem, written in bold, orange math. Step 1. First, recall the subtraction of a negative. A minus negative b equals a plus b. Now simplify the inside of the absolute value exactly in this order. Negative 2 minus negative 3 equals negative 2 plus 3 equals 1, which is greater than 0. Step 2. Apply the definition of absolute value. If x is greater than or equal to 0, then the absolute value of x equals x itself. Since the inside evaluated to 1, which is positive, we write the absolute value of negative 2 minus negative 3 equals plus bracket negative 2 minus negative 3 bracket equals 1. Final answer, 1. We follow the exact two-step structure. Simplify inside first, then apply the absolute value definition. Let's clearly state the example. Step 1. Determine the sign of the quantity inside the absolute value. 1 minus square root of 2 is negative. Step 2. Apply the definition of absolute value. The definition says absolute value of x equals x if x is non-negative, and equals negative x if x is negative. Because 1 minus square root of 2 is negative, we use the second case. The absolute value of 1 minus square root of 2 equals negative of parentheses 1 minus square root of 2. Now, we simplify the negative sign through the parentheses. Finally, we state the result and give a quick intuition check. The absolute value of 1 minus square root of 2 equals square root of 2 minus 1, which is a positive number measuring the distance between 1 and square root of 2 on the number line. In this example, we will simplify the absolute value of the difference of 2 square roots, exactly following the definition of absolute value and a careful sign analysis. Step 1. Determine the sign of the expression inside the absolute value. The square root function is increasing, so if 3 is less than 5, then the square root of 3 is less than the square root of 5. That means the quantity square root of 3 minus square root of 5 is negative. Step 2. Apply the definition of absolute value. If the inside is negative, then the absolute value equals the negative of that inside quantity. Since square root of 3 minus square root of 5 is less than 0, we write absolute value of square root of 3 minus square root of 5 equals negative, open parenthesis, square root of 3 minus square root of 5, close parenthesis. Now distribute the negative sign to get square root of 5 minus square root of 3. Quick challenge. Anytime you see an absolute value with radicals, first compare the radicands to decide the sign before removing the bars. That single check prevents sign mistakes. We want to simplify the square root of 4 minus 2 root 3. Step 1. Write the expression clearly. Step 2. Rewrite the number 4 as 3 plus 1 to prepare a perfect square pattern. Step 3. Recognize the perfect square trinomial. Since 3 equals the square of root 3, and 1 equals 1 squared, and the middle term matches negative 2 times root 3 times 1, we can rewrite the inside as the quantity root 3 minus 1 squared. Step 4. The square root of a square is the absolute value of the base. Step 5. Decide the sign of root 3 minus 1. Step 5. Decide the sign of root 3 minus 1. First, let's put the problem on screen as our example. Step 1. Recognize the perfect square trinomial. We see x to the fourth plus 2x squared plus 1 equals the square of x squared plus 1. We'll place a small rule box to remind us of the pattern as squared plus 2. A b plus b squared equals the square of a plus b. Now we rewrite the radicand as the square of x squared plus 1, still under the square root. Step 2. Use the definition of the square root of a square. The square root of a squared equals the absolute value of a. We'll display the rule. Applying it, the expression becomes the absolute value of x squared plus 1. Step 3. State the positivity condition for removing absolute value bars. Since x squared is at least 0 for any real x squared plus 1 is strictly greater than 0. We'll show a quick note. In the reference solution, this is written on the same line after a semicolon. Absolute value of x squared plus 1 semicolon x squared plus 1 greater than 0. Step 4. Because the inside is positive, the absolute value equals the positive expression itself. The reference solution shows a leading plus sign, plus parentheses x squared plus 1. We'll show the removal rule. Then write plus x squared plus 1. Step 5. Finally, we drop the unnecessary positive sign to get the simplest form. The result is x squared plus 1. As a quick visual check, the graph of y equals x squared plus 1 is a parabola shifted up, so it never touches 0. That is why the absolute value disappears. Therefore, the simplified value of the original radical is x squared plus 1, valid for all real x. Valid for all real x. Example. We will simplify the radical using the exact algorithm shown. Square root of 2021 times 2025 plus 4, with the information that x equals 2021 and x plus 4 equals 2025. Step 1. Write the initial expression and the conditions. Step 2. Substitute 2021 by x and 2025 by x plus 4. Step 3. Distribute x across the parenthesis. Step 4. Recognize a perfect square trinomial x squared plus 4x plus 4 is the square of x plus 2. Step 5. The square root of a square equals the absolute value. We keep the condition that x is bigger than negative 2. Step 6. Since x is 2021, the condition x greater than negative 2 is true, so the absolute value drops and becomes x plus 2. Step 7. Substitute x equals 2021. Step 8. Add to obtain the final result, 2023. First, the example. We want to simplify the absolute value of 1 minus sine x. Step 1. Determine the range of the term inside the absolute value. Sine oscillates between negative 1 and positive 1. Therefore, we write negative 1 less than or equal to sine x less than or equal to positive 1. Step 2. Deduce the sign of the expression 1 minus sine x. Subtracting sine x from 1 shows that 1 minus sine x is always non-negative. So we write 1 minus sine x is greater than or equal to 0. Step 3. Apply the definition of absolute value. If a quantity is non-negative, its absolute value equals itself. Therefore, the absolute value of 1 minus sine x equals plus, open parenthesis, 1 minus sine x, close parenthesis. Step 4. Simplify by removing the explicit plus sign. So the expression becomes 1 minus sine x. That is the simplified result without absolute value bars. In this lesson, we will evaluate the absolute value of a radical expression using a clean algebraic comparison. The goal is to simplify the absolute value of cube root of 2 minus cube root of 3 minus cube root of 4 plus cube root of 5. Step 1. We will use the classic identity for the difference of cubes. Open parenthesis, a minus b close parenthesis times a squared plus a b plus b squared equals a cubed minus b cubed. Step 2. Solve this identity for a minus b. As long as the sum of squared plus ab plus b squared is not 0, we can write a minus b equals a cubed minus b cubed divided by a squared plus ab plus b squared. Step 3. We apply this to two helpful differences. First, cube root of 5 minus cube root of 4. That equals 5 minus 4. all over the sum of three cube root terms, cube root of 25 plus cube root of 20 plus cube root of 16. Next, cube root of 3 minus cube root of 2 equals 3 minus 2 over cube root of 9 plus cube root of 6 plus cube root of 4. Step 4. Compare denominators. Each term in the first denominator is larger than the corresponding one in the second. 25 is greater than 9, 20 is greater than 6, and 16 is greater than 4. Therefore, the first denominator is larger, so its reciprocal is smaller. This means cube root of 5 minus cube root of 4 is less than cube root of 3 minus cube root of 2. Step 5. Rewrite the inside of the absolute value as two differences grouped together. Open parenthesis cube root of 2 minus cube root of 3 close parenthesis plus open parenthesis cube root of 5 minus cube root of 4 close parenthesis. Using our inequality, this total is less than 0. Step 6. Because the quantity is negative, its absolute value equals the additive opposite. So we flip the signs. Final answer. The absolute value simplifies to cube root of 3 plus cube root of 4 minus cube root of 2 minus cube root of 5. In this video, we will simplify the expression, the absolute value of x plus 2 minus 2, exactly following the step-by-step algorithm shown in the prompt image. We will use only the definition of absolute value and write each line in the same order. First, the definition of absolute value. If it is greater than or equal to 0, then the absolute value of it equals a. If it is less than 0, then the absolute value of it equals negative a. We'll apply this with it equal to x plus 2. We begin by writing the target expression. Case 1. If x is greater than or equal to negative 2, then x plus 2 is greater than or equal to 0. So the absolute value of x plus 2 equals plus x plus 2. We restate that equality on its own line. Now substitute this into the original expression. Absolute value of x plus 2 minus 2 equals left parenthesis x plus 2, right parenthesis minus 2. Simplify. The plus 2 and minus 2 cancel, leaving x. A quick visual. The boundary between the two cases is at x equals negative 2. Case 2. If x is less than negative 2, then x plus 2 is less than 0. So the absolute value of x plus 2 equals negative, left parenthesis x plus 2, right parenthesis. Again, restate that equality on its own line. Now substitute it back into the expression. Distribute the negative sign to get minus x minus 2, then minus 2 again. Combine the constants. Minus 2 minus 2 gives minus 4. Finally, we express the result as a single piecewise expression, matching the exact structure from the solution list. Summary. Using only the definition of absolute value and following the exact line order, we obtain that the absolute value of x plus 2 minus 2 equals x when x is greater than or equal to negative 2 and equals negative x minus 4 when x is less than negative 2. First, recall the definition of absolute value. The absolute value of x equals x if x is greater than or equal to 0 and equals negative x if x is less than 0. To know which branch we should use, we will compare two group parts. We compare fifth root of 2 minus 1 with fifth root of 4 minus square root of 3. Numerically, fifth root of 2 is about 1.1487, and fifth root of 4 is about 1.3195, while square root of 3 is about 1.7321. Therefore, fifth root of 2 minus 1 is positive, about 0.1487, and fifth root of 4 minus square root of 3 is negative, about negative 0.4126. Hence, fifth root of 2 minus 1 is greater than fifth root of 4 minus square root of 3, which implies that the whole inside expression is less than 0. Since the inside is negative, we use the second branch of the definition. The absolute value equals the negative of the inside. Now distribute the negative sign across all four terms. Then reorder the terms so like signs read naturally. In this lesson, we will simplify the expression absolute value of x minus 2 plus absolute value of x, and we will do it step by step using a number line and case analysis. Here is the problem statement. We will keep all math on screen in bold and connect each step to an intuitive diagram. First, recall the definition. The absolute value of a quantity t equals t if t is greater than or equal to 0 and equals negative t if t is less than 0. We will apply this definition to the expressions x and x minus 2. Next, draw a number line and mark the critical points 0 and 2. These points decide the sign of x and the sign of x minus 2. Case 1. Values to the left of 0 where x is negative. In this region, absolute value of x equals negative x, and absolute value of x minus 2 equals 2 minus x. So the sum equals 2 minus 2x. Case 2. Between 0 and 2, x is non-negative, but x minus 2 is non-positive. Then absolute value of x is x, and absolute value of x minus 2 is 2 minus x. The sum simplifies beautifully to the constant 2. Case 3. To the right of 2, both x and x minus 2 are non-negative. Then absolute value of x is x. Absolute value of x minus 2 is x minus 2, and the sum becomes 2x minus 2. Putting the three cases together, we have a clean piecewise description of the function. This is the complete and correct simplification of absolute value of x minus 2 plus absolute value of x. To build geometric intuition, let us also look at the graph. Notice the constant flat segment between 0 and 2 at height 2, a line with negative slope to the left, and a line with positive slope to the right. In this video, we will evaluate the expression x times the absolute value of y plus y times the absolute value of x, under the condition that x and y are reciprocals. That means y equals 1 over x, and x is not equal to 0. We begin with the expression x times the absolute value of y plus y times the absolute value of x. Substitute y equals 1 over x directly into the expression. Next, we use the property, the absolute value of 1 over x equals 1 over the absolute value of x. Applying that rule gives x divided by the absolute value of x plus the absolute value of x divided by x. To finish, we split into two cases using the definition of absolute value. When x is positive, absolute value of x equals x. When x is negative, absolute value of x equals negative x. Case 1, x is greater than 0. Then absolute value of x equals x. So the expression becomes x over x plus x over x, which is 2. Case 2, x is less than 0. Then absolute value of x equals negative x. So the expression becomes x over negative x plus negative x over x, which is negative 2. Therefore, the original expression equals 2 when x is positive, and negative 2 when x is negative. Here is the final piecewise answer. As a quick check, take x equals 2, so y equals 1/2. The value is 2 times the absolute value of 1/2 plus 1/2 times the absolute value of 2, which equals 2. 4x equals negative 3, y equals negative 1/3. The value becomes negative 2. This matches our piecewise result. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.